Welcome. So let's have a summary for the two-sided and one-sided test and how to perform the test of hypotheses. So as we have seen, we always have the null hypothesis, for example on the mean as mu equal to mu naught. This is the same for two-sided and one-sided. So the difference is always in the alternative hypothesis. So if we have the alternative hypothesis as mu does not equal to mu naught, we have two-sided test. If it is larger than or less than, so we have one-sided test. So now we have seen three methods or methodologies to perform the test or to check and examine our hypothesis. We have seen the test statistic, which is Z naught. Z naught in fact is used usually when we know the variance sigma square or the standard deviation sigma of the population. We also have seen the confidence interval. We also have seen the p-value. So this is the summary for the test statistic. In case of sigma square, which is the variance of the population to be known, we have the same test statistic for two-sided or one-sided tests. Z naught always equals to sample mean minus hypothesized population mean divided by sigma over square root of n. So this is the alternative hypothesis. In case of two-sided, we will reject if absolute value of Z naught is larger than Z alpha over 2, which means that Z naught is outside the interval of acceptance. So in case also, if we have the H1 or alternative hypothesis to be mu is larger than mu naught, which mu naught is a specific value, we will reject the null hypothesis if Z naught is larger than Z alpha. Also, on the other hand, if the H1 is mu is less than mu naught, we will reject the null hypothesis in case of Z naught is less than minus Z alpha. Here we have minus Z alpha. Also, we can write Z1 minus alpha. Also, we have seen the confidence intervals. So for the two-sided hypothesis, we have this confidence interval as we have seen. In fact, we can derive from the two-sided confidence interval the one-sided confidence intervals. Here, in the two-sided confidence intervals, we have Z alpha over 2 and here Z alpha over 2. But in the one-sided, we only replace Z alpha over 2 to be only Z alpha because alpha is only in one side, and here also Z alpha because alpha is only in one direction or one side. As we have seen, we will reject the null hypothesis in case of the mu naught or hypothesized mean is not included within the confidence interval. Also, we have seen the methodology of p-value. We have seen that in case we have a two-sided test, the p-value equals 2 multiplied by 1 minus phi of Z naught, where phi of Z naught is the cumulative distribution function. So the cumulative distribution function computes the area under the curve from minus infinity until the value of Z naught. So we have 2 here for the two-sided. In case of one side, we don't have 2. This is, for example, one-sided test. We have a mu larger than mu naught. We have, this is called the probability above Z naught, because we have Z naught, we have the cumulative, which is the area under the curve from minus infinity to Z naught. So we calculate the p-value as 1 minus phi of Z naught, because p-value is the probability above or larger Z naught. In case of mu is less than mu naught as an alternative hypothesis, we have the p-value to be the probability below Z naught, or the area under the curve, which is from minus infinity until Z naught. So we can directly calculate the p-value as phi of z0 or the cumulative distribution function of z0. Using the p-value methodology, we will reject h0 only if the p-value is less than alpha. So if p-value is less than alpha, we will reject the null hypothesis. On the other hand, if the p-value is larger than alpha, we are going to fail to reject the null hypothesis.